Learning objectives. At the end of this topic, you will be able to understand the term motion of an object, estimate time taken for different events, explain the concept of speed of a body, state basic units of time and speed, represent given distance and time information as distance-time graph. Introduction. Observe the video. The motorcycle is traveling at a speed of 70 km per hour. The car is traveling at a speed of 100 km per hour. Speedometer A shows the speed of the motorcycle. Speedometer B shows the speed of the car. What is speed? The numbers on the board indicate the distance that needs to be traveled to reach a destination. What is distance? Let us find out. Motion. When an object changes its position with a lapse of time in respect to a stationary object such as a building, electric pole, etc., the object is said to be in motion. Are there different types of motion? Motion in straight line, circular path, curved path, curvilinear motion, rotating wheel, periodic motion. Some motions repeat, but they don't repeat in the same interval. Non-periodic motion. Distance. A boy travels 5 kilometers towards the east. Then he travels 1 kilometer towards the south. Finally, he travels 5 kilometers towards the west to reach point T. What is the total length of the path traveled by the boy? The total length of the path traveled by the boy is 5 kilometers plus 1 kilometer plus 5 kilometers is equal to 11 kilometers. What do you call the total length of the path traveled by the boy? The total length of the path traveled by the boy is the distance. Distance is the total length traveled by an object from one point to another. It does not show the direction of the moving object. Distance is a scalar quantity. It has only magnitude. The SI unit for distance is meter. Let us understand about speed. A car travels 40 kilometers in half an hour. A motorcycle travels the same distance in 1 hour. Which of these vehicles will reach the destination earlier? The car will reach the destination earlier than the motorcycle. Why? The car takes half an hour to travel 40 kilometers. The motorcycle takes 1 hour to travel 40 kilometers. The distance traveled by an object in a unit of time is referred to as speed. What is the speed of the car and the motorcycle? The speed of the car is 80 kilometers per hour. The speed of the motorcycle is 40 kilometers per hour. Since the car is traveling at a speed faster than the motorcycle, it will reach its destination earlier. What is the SI unit of speed? The SI unit of speed is meter per second. There are many ways to measure time. Let's listen to these sounds. Click on each sound to hear. Can we use these sounds to measure time? Why? Sounds 1 and 2 are repeated uniformly. These sounds are repeated at the same beat. Sounds 1 and 2 can be used to measure time. Let's listen to the sounds again. Which of these sounds can you use to measure time? Click on each sound to listen. Sound 1 is repeated uniformly. We can use sounds that are repeated uniformly to measure time. Thus, we can use the sound to measure time. Sound 2 is repeated uniformly. We can use sounds that are repeated uniformly to measure time. Thus, we can use this sound to measure time. Sound 3 is not repeated uniformly. This sound is not repeated at the same beat. We cannot use this sound to measure time. Have you seen this type of clock? This is a grandfather clock. It has a pendulum in it. What do you observe about the pendulum? Discuss this with your friends.
The pendulum swings from one side to the other.
Is the swing repeated uniformly? Can we use a pendulum to measure time? Think about it. Click Check Answer to find out.
The swing of the pendulum repeats uniformly. We can use a pendulum to measure time.
The pendulum and dripping water are used at the same time to measure the time taken for the ball to roll from point A to point B. Click on the ball to see how long it takes to roll from point A to point B. It takes 4 swings of the pendulum and 6 drops of water for the ball to roll from point A to point B. The swings of the pendulum and drops of water are events that are repeated uniformly. Although they're repeated uniformly, they do not give the same measurement for the time taken. We need to use tools to measure time accurately. What are the tools we can use to measure time? What are the metric units for time in the metric system? Discuss this with your friends. Here are the tools that we can use to measure time. What can you see on a clock? Click on each of the clocks to see. This is a wall clock. There are hands, scales, and numbers on its face. A clock has an hour hand, a minute hand, and a second hand. This clock shows time by moving its hands. The hour hand is used to measure hours. The hand moves from 3 to 4 to show the time lapse of 1 hour. The minute hand is used to measure minutes. This hand moves from 10 to 11 to show the time lapse of 5 minutes. The minute hand passes through 5 small parts. Each part equals 1 minute. The second hand is used to measure seconds. The hand moves from 12 to 2 to show the time lapse of 10 seconds. Each small part that the second hand passes through equals 1 second. Seconds, minutes, and hours are the units of time in the metric system. This is a digital clock. The numbers in the clock show the time. The number changes as time passes. Look at the clock. It is 3:25 and 30 seconds now. Seconds, minutes, and hours are the units for time in the metric system. There are different tools that we can use to measure time. In different situations, we use different tools to measure time. Measurement of speed. Prakash and Pradeepa participated in a 200-meter running race. Prakash finishes the race in 20 seconds and Pradeepa finishes it in 25 seconds. Who ran faster? Obviously, Prakash ran faster compared to Pradeepa. What do you infer from this example? It is very clear that both of them have run the same distance, but one of them was faster than the other. In simple words, we can say Prakash covers more distance in a unit time. Hence, speed is given by speed is equal to distance covered by an object divided by the time taken by the object to cover the distance. The rate at which Prakash was running is given by 200 meters divided by 20 seconds. That is equal to 10 meters per second. Whereas, the rate of running for Pradeepa is given by 200 meters divided by 25 seconds. That's equal to 8 meters per second. Hence, Prakash won the race. Distance, speed, measuring devices. Have you seen meters that are fitted on top of scooters, motorcycles, and dashboard of cars, buses, and trucks? You will see that in one of the meters it is written kilometers per hour in one corner. You will see that in one of the meters it is written as km per h in one corner. This meter shows the speed of moving vehicle directly and is called the speedometer. There is also another meter in the middle of the speedometer that measures the distance moved by the vehicle in kilometers. This meter is called odometer. Distance time graph. If a vehicle covers a distance of 5 kilometers every hour and travels for 5 hours, the time distance time graph for the given vehicle can be plotted as follows using the table given below. When distance covered by an object and time taken to cover the distance is represented on a graph, the graph is called distance time graph. Making a graph. Draw two perpendicular lines to represent the two axes and mark them as x and y. Decide the quantity to be shown along the x-axis and that to be shown along the y-axis. In this case, we show the time along the x-axis and the distance along the y-axis. Choose a scale to represent the distance and another to represent the time on the graph. For the motion of the car, scales could be time, 1 hour is equal to 1 centimeter. Distance, 5 kilometers is equal to 1 centimeter. Mark values for time and distance on the respective axes according to the scale you have chosen. For the motion of the car, mark the time, 1 hour, 2 hour, and so on the x-axis from the origin, O. Similarly, mark the distance 5 kilometers, 10 kilometers, and so on the y-axis. Now you have to mark the points on the graph paper to represent each set of values for distance and time. After 1 hour, the car has moved a distance of 5 kilometers. To mark the set of values, look for the point that represents 1 hour on the x-axis. Draw a line parallel to the y-axis at this point. Then draw a line parallel to the x-axis from the point corresponding to a distance 5 kilometers on the y-axis. The point where these two lines intersect represents the set of values on the graph as shown. Similarly, mark on the graph paper the points corresponding to different sets of values. The image shows the set of points on the graph corresponding to the positions of the car at various times. Join all the points on the graph as shown. It is a straight line. This is the distance time graph for the motion of the car. If the distance time graph is a straight line, it indicates that the object is moving with a constant speed. However, if the speed of the object keeps changing, the graph can be of any shape. Summary. Let's summarize the topic. The distance moved by an object in a unit time is called its speed. Speed of objects help us to decide which one is moving faster than the other. The speed of an object is the distance traveled divided by the time taken to cover that distance. Its basic unit is meter per second, m per s. Periodic events are used for the measurement of time. Periodic motion of a pendulum has been used to make clocks and watches. Motion of objects can be presented in pictorial form by their distance time graphs. The distance time graph for the motion of an object moving with a constant speed is a straight line. The speed of a vehicle can also be measured by using a speed gun. How does the speed gun measure the speed of a vehicle? Where is the speed gun used? Use books and the internet as your reference. Prepare a report. Present your findings to your class. Peter will be cycling to Tambaram to visit his friend, Bob. There are 4 different routes that lead to Bob's house. He wants to reach Bob's house in the shortest time possible. Let's help Peter to decide which route to take. Find out how long it takes to ride along each route. Measure each route in centimeters on the activity sheet. Which route should Peter take? Discuss this with your friends.